HCl, when not dissolved in water, exists as a gas under normal conditions. If 13.0 milliliters of HCl gas at 1.03 atmospheres and a temperature of 23.7 degrees Celsius were dissolved in 500.0 milliliters of water, what would be the pH of the resulting solution? Well, there's a lot of numbers in this problem, but the first thing I notice is that so many of them refer to the gas. So I'm going to start with my ideal gas law. I have my pressure of 1.03 atmospheres, my volume of 0.0130 liters. Remember, there are specific units for each one of these values in the ideal gas law, and we have to convert them appropriately. We do not know the number of moles. The gas constant R is always 0.0821 liters atmospheres per mole Kelvin, and our temperature would be Kelvin equals degrees Celsius plus 273, 23.7 degrees Celsius plus 273 gives me 296.7 Kelvin. So we can solve for our number of moles. We would have 1.03 times 0.0130 divide by 0.0821 divide by 296.7, and we come up with 0.0000550. So we keep the 5, the 4, and the 9. We look to the next number to see if it rounds up, but as the 9 rounds up, it trips the next number as well. So for 3 significant figures, the same as our pressure and our volume, we would need 0.550. And this is moles of HCl gas. Well, if we dissolve this in 500 milliliters of water, then we can calculate a molarity, which is our number of moles divided by liters. Converting the milliliters to liters before we do, we would divide by 0.5000, and we'd end up with a molarity of 0.00110 molar hydrochloric acid. Now, we're not quite done, because we want to know the pH, not just the molarity, of the resulting solution. So to calculate the pH from a molarity, we need the negative log of the hydrogen ion concentration, which would be the negative log 0.00110 molar. Which would give us a final pH of 2.959. And that would be our final answer.